Hello and welcome to Venn Diagrams. You've probably done these before in the past, but we're going to review a little bit. Go ahead and pause the video and copy down this information and these two diagrams so you have pictures of what we're talking about. Okay, now play the video. If we're talking about two different events that are in a sample space, so two different possible outcomes, like let's suppose event A is that you are male and that event B is that you have blue eyes. Then we could say the union of those two is basically saying you can be in our little special club if you are in A or if you are in B. Union always means or. And usually when we have or, and we're going to add probabilities together. But what it really means here is that we're trying to find the probability of being in A or B. So you can be in the club if you are a male or if you have blue eyes. So all of the males are in, and all of the people with blue eyes are in, and even the people that are both are also in. All these people can be in the club. The only people that are not in the club are the people who are not male and do not have blue eyes. In the second one, A and B, that means the intersection. So now in order to be in the club, you have to both be a male and you also have to have blue eyes. So only these ones in the middle are going to apply. Only these can be in the club. And these guys might say, but I'm a boy, I want in. Too bad, you also have to have blue eyes and you do not have blue eyes. And these people might say, but I have blue eyes. Yeah, but you're girls, you don't count. You have to be in the middle, you have to be both in order to be in our answer club. And we can use these two ideas to figure out a whole bunch of different probabilities. So here's a couple more examples. What about the intersection of A and not B? We've talked about this being the complement. So now in order to be in our club, you have to both be in this group and also not be in that group. So you would have to be a boy that does not have blue eyes. So that means we're only talking about these boys here because those boys have blue eyes. So all the blue eyes are out, only the boys here are in. The next example shows what about not A and not B, the complement of A and the complement of B. Well now, if you are a boy, you're out. If you are blue eyes, you are out, so only the people here in the outside could be in the club. So here's 4 examples for you. What I'd like you to do is I'd like you to pause the video now, copy down this information, these questions, and this diagram, and try to answer these questions the very best that you can. Go. And play. Here we go. First we're going to try to figure out the number of people that are in the club altogether. Okay, so in this case, we're just trying to find numbers of people. So 15 people play tennis, 27 people play tennis and hockey, 26 people only play hockey, and 7 people don't play anything but they're in the club. And we add all these up and we would get our answer. Oh boy, what is it? 52 plus, 53 plus 6 is 60, that's 75. So we have 75 people total that are in the club. Okay, how many people play hockey? Well, we've got the people that play hockey and tennis, plus the people that play hockey but don't play tennis. So that is 53 people. How many people play both sports? Well, that's easy. That's 27 right here. How many people play neither sport? Well, that's these guys over here. There's 7. And how many people play at least one of the 2 sports? Well, that would be the tennis people, plus the both, plus the only hockey people. What's that? 53 plus 15 is 68. Okay? Next example. Pause the video and try this. Copy this question down. Try to answer it yourself. Draw a diagram and see if you can answer these questions. Okay? And play. Let's see if you're right. We're going to draw a Venn diagram here. And we'll make this one physics. And we'll make this one chemistry. Okay? And they tell us that there's 30 students altogether. 19 study physics together. So, but that's not 19 here or here. That's together 19. 17 study chemistry. 15 study both. Okay, so here's 15. They study both. Which means how many more people study physics out of the 19? There were 15 here, so that's 4 left. And out of the 17 chemistry people, 15 are here, so that's 2 left. Now how many students do we have altogether? Right now that's 19, 21 we've accounted for. there are 30 students, so there must be 9 that don't do either of them. Now we can answer our questions. How many find the probability that a random student, so now we're talking about probability, right, which is the number of ways our thing can happen out of the total. So probability is going to be, both is going to be 15 out of the total, which is 30, and we can just reduce that to be 1/2. How many people, what's the probability that we choose a person at random and they have at least one of these? Well, 4 plus 15 plus 2, that is 21 of the 30 people do at least one. We can divide those by 3s. That's 7 out of 10. How many people do physics but not chemistry? Well, that is just these people here. 4 out of the 30. I can reduce that to be 2 out of 15. And then lastly, exactly 1 of the subjects, so not 2. So that would be the physics people plus the chemistry people. So that's 6 are doing only 1 subject out of the 30, which reduces to be 1/5. Not sure why that didn't work. There we go. Good luck with your Venn diagrams. Have a great day.